In this video, we'll look at how to determine the exact value of trig functions. In particular, we'll start with sine of 330 degrees. So it begins with a sketch. It doesn't have to be beautiful, it's rough, but you do need to label the arrows and the x and y axis. And then where is 330 degrees in terms of rotations? Well, start with the initial arm, it's always on the x-axis like so, and rotate 330 degrees, 90, 180, 270. So that puts you into quadrant 4. Label that rotation, 330. Okay, well if we're in quadrant 4 here with 330 degrees, then what's left here for beta? Let's call that related acute angle B, or beta, the related acute angle. That related acute angle is whatever's left over from a whole 360 rotation. Take away that 330, so the beta is 360 minus 330, which is 30 degrees. Why is that useful? Well, now we can say, okay, the sine of 330 is going to be equivalent or equal to the sine of 30 degrees, with one exception. We have to check the cast rule, C-A-S-T. In quadrant 4, only cosine is positive. So to be equivalent, this sine 330 to sine of 30 degrees, we need a negative here. Now, we could theoretically do this on our calculator, but we're trying to figure out the exact value. So to do that, we'll need the special triangle, the one with 30 degrees in it. You could draw both if you wanted, but I'm only really interested in the one with 30 degrees. So 30 degrees here, which means the little side goes here, 60 degrees here, so the big side, root 3, goes here, and 2. So what's the sine of 30 degrees? That's 30 degrees is opposite over hypotenuse, which is 1 over 2, and we have our answer. The sine of 330 degrees is the same as negative sine 30, and using our special triangle we got that was a half, so it's negative 1/2. Done. This second question, we're going to begin much the same way. Let's start with a sketch. This is our y-axis, and this is our x-axis, labeled in arrows. Start with an initial arm. You have to put that for good communication. You're starting from here and rotating to wherever cos is negative. You don't have to write it down, the cast rule, but it can help. Where is cosine negative? Well, in quadrant 2 and in quadrant 3, cosine's negative. So let's call this rotation theta 1, and let's call this rotation theta 2. And let's label inside here the related acute angle B, or beta. That's the angle of each terminal arm to the x-axis. Let's calculate the related acute angle. And when you do a related acute angle, you take away the negative. That is, you want to solve just inside an imaginary triangle here, what's this angle beta? Inside a triangle, there are no negatives. Triangles can't have negatives. So we're looking for the cosine of beta, which is root 3 over 2. We know it has to have that same relationship, but since it's a triangle, it's positive. To solve that, you inverse cos. But instead of putting that on your calculator, we want to do exact value. So we go to our special triangle and say, where does the inverse of cos, where do you get root 3 over 2? How can you come up with a root 3 over 2? Which angle? You really only have two choices here. It's either the 30 or the 60, because the triangle with root 3 over 2 is this one. So looking at this triangle, I got to get root 3 to be the adjacent, because it's cosine, and 2 to be the hypotenuse. If I chose 60, it would be wrong, because this would be adjacent 1. It's 30 degrees. That's because the adjacent side is root 3, and the hypotenuse is 2. So the beta is 30 degrees. And what I know is that this angle with the x-axis is 30 degrees. But what I want to solve for is theta 1. So to solve for theta 1, that's the same, it's always the same for quadrant 2. I'm in quadrant 2 here with theta 1. It's the same as 180, make a full half rotation, I should say, just a half rotation, but then take away this beta. That's 180, take away 30 degrees. And so the first theta that works, there's going to be two possible answers, is 150. The second theta that works is in quadrant 3. In quadrant 3, always the same formula. Do that half rotation and then add on this beta. It's 180 degrees plus whatever the beta is here. 180 degrees, I must put a degree there, plus 30 equals 210. And we have our two answers. Notice you could actually rotate more and more. So the question should specify here, it's my fault for not writing it, we're looking at just rotations where theta is between 0 and 2 pi. And sorry, theta and 360. And so, again, you could rotate all the way around and then do it again and have another one, but between 0 and 360, there's only two possible answers that give you root 3 over 2. One is 150, the other is 210. So that's how to determine the exact value of trig functions using degrees. When you get to grade 12, we'll do it with radians. That's what I almost gave away here. And you can watch that video if you'd like.